Page 20. Okay, so let's look at this. This is called we are going to simplify complex fractions. And let's define complex fractions. So when you see something like this, 2/3 divided by 4/5, or 4/6/7. When you see something like this, it's called a complex fraction because it's very complicated. So we have a fraction in a fraction with another fraction in there, or an integer and a fraction in a fraction. That is not acceptable. If you have this on your test, then it's just going to be half off, or in this chapter, it's just going to be wrong. So you have to simplify. You cannot have a fraction in a fraction in a fraction, that kind of thing. So it has to be just one fraction. So complex fraction is when there is one or more fraction in a fraction. A fraction should just be a numerator and a denominator only. Cannot have a fraction and a fraction and all that kind of stuff. So when that happens, we have to simplify. For example, this is just a number example, and I do want to draw your attention to this fraction bar, this line. There's always going to be one line that's a little longer than the rest, and I will try to make it more dramatic in the test so you know what it is. Because what happens is a lot of people will forget which one is the long fraction bar, and then they will start drawing things like this. And now they're really confused. 2 divided by 3 divided by 4/5. But that's not what the question says. This is the long fraction bar. It's 2/3 divided by 4/5. Okay, 2/3 divided by 4/5, just write it out. And then we know that when we divide by a fraction, we multiply by the reciprocal. So this is 10/12 or 5/6. Okay, now eventually, I don't want you to write the fraction divide by fraction part. I want you to do that in your head. So this part, 2/3 divided by 4/5. This part is irrelevant, or it's redundant. You don't have to write this out later on. So next year, I'm just going to take shortcuts and assuming you guys can do this in your head. So we know that it's 2/3 divided by 4/5. I want you to mentally flip this up. So mentally flip this fraction up and then just do multiply right away. Just save a step because you don't want to write this extra step out. Good? Okay. All right. So now let's do a example like this. Fraction plus a fraction over a fraction plus an integer. This is a very, very complicated fraction. I'm going to teach you two methods. Method 1 is what I always do, but it's long. But I know for sure I will always get the right answer. Method 2, only do it if you don't feel like you will make mistakes and you understand what method 2 is actually doing. Because once people do method 2, they will get half of the test wrong because they're applying method 2 to things they cannot do method 2 too. So method 2, caution. Okay, method 1 will always get you the correct answer. All right, let's copy down the question first. So copy down that question and then we'll do method 1 together. All right, method one is simple. All you do is one at a time. So add those fractions together, which is what you learned last Friday. Make sure they have common denominator. And then add the fraction together in the bottom. And then make sure they have common denominator. The one thing I don't want you to do is do side notes. Don't go like this and write it on the side. Do this on the side and then put it back together. Don't do that. It is very crazy. What you want to do is just write it all together in one shot. Write the fractions here, write the fractions here, rewrite. don't do sidebars. You guys know what I'm saying? Okay, so go ahead and add the two fractions together on the top, on the bottom, and then we will check them together. We're going to take a little bit more, steps to do this, but I want you to write everything out. Okay, so on the top, what's the common denominator in the numerator? XY. So this guy needs a y. Please write y over y. Don't just write y, because it's going to confuse you later on. Am I multiplying just a y, or am I multiplying y over y? That's a very different thing. This one's missing an x over x. In the denominator, what's the common denominator? What's the common denominator between 1 over y and 1? Y. So just this guy needs a y. All right, this is what I mean. Please do not do sidebars. We're going to write y over xy plus x squared over xy over 1 over y plus y over y. Nothing on the side. Don't write something on the side, come back together, and then on the side again. It's too confusing. Next, add them together. X squared y plus y over xy divided by, make that long division bar dramatic so you are not confused later on which one is the long one. 1 plus y over y. At this point, you reduce 3 fractions in a fraction to 2 fractions in a fraction, so you're making progress. Now you're going to do the same thing you did before, so fraction divided by fraction equals, every time you write a new line, write equals x squared plus y over xy divided by 1 plus y over y, or use the shortcut and flip it up in your head, equals x squared plus y over xy times y over 1 plus y. Okay, at this time, try to do some cross-canceling if it is possible. In this case, y's will cancel. We get x squared plus y over x times 1 plus y. Okay, this is method 1, so slow, but you'll be sure that you have the right answer. So add the 2 fractions together on the top, add the 2 fractions together on the bottom, so basically simplify those first, and then divide the 2 fractions. All right, let me show you method 2. Okay, method 2. Copy the question again. Okay, method 2. Method 2 is a lot shorter, so if question 1 takes you 5 minutes, method 2 will probably take you 1 minute. So it is a really fast method, but you have to be careful. First of all, to do method 2, you have to look at the LCD, the least common denominator, for every single thing that's in the fraction. So what is the least common denominator for all 4 terms? XY. So what we're going to do is we're going to multiply the LCD to everything. So we're going to multiply xy over xy. Okay, what this means is we are going to distribute to everything. The numerator goes to the numerator, the denominator goes to the denominator. Okay, so what essentially this looks like is xy times 1 over x plus xy times x over y over xy times 1 over y plus xy times 1. Okay, obviously you're not going to write this out every single time. The reason to do method 2 is take a shortcut, so you don't want to write out the distribution. The first time, I'm going to show you how to do it. Okay, so now xy times 1 over x. Which part is going to cancel? What's going to cancel? X. So what are you left with? Y. Okay, xy times x over y. What's going to cancel? Y. Okay, what's left over? X squared. Okay, denominator. Xy times 1 over y. Okay, let's just talk about what's going to be left over. X. Okay, and then xy times 1 is just xy. And then actually you're done. So that intermediate step is actually unnecessary if you can do this in your head, and then pretty much you're done. So this is very fast, but very easy to make mistakes if you don't understand what this method is actually trying to do. So if you don't ever want to make any mistakes at all, don't do method 2. But it is going to save you a lot of time. All right, so let's have you try this one. All right, so I'm going to show you method 1 and method 2, but the whole idea is please rewrite, and then that way you don't make a mistake. And just, make sure that you write every single step out. On the bottom, the common denominator is xy, so you need to write multiply by y over y, and then this multiply by x over x. When you rewrite, write the whole thing again, not just the denominator part. Write the x over, because you're going to forget I still need to divide. Okay, so this is x over xy plus x over, the first one is y. Y over xy plus x over xy. This now becomes x over x plus y over xy. At this point, please make sure this line is very dramatically longer, much longer than the other one, so you don't get confused. Okay, and then x divided by x plus y over xy. So x times xy over x plus y, which is x squared y over x plus y. Okay, that's method 1. Any questions? Are you sure? Did you, question?
It's more time to write it down.
Oh, okay. How many people got this one? Give me a thumbs up. Okay, half of the class. All right, let's try method 2. Method 2 says we are going to multiply everything by the least common denominator, which is xy. It's xy over xy. Okay, what you're going to do is just distribute numerator to numerator, denominator to denominator. Okay, x times xy is just x squared y. In the denominator, xy times 1 over x. Which one will cancel? Okay, Daniel, which part cancels? xy times 1 over x.
Yeah.
Okay, Allison, what's left over? Y? Good. So y is left over. Okay, Samantha, xy times 1 over y. Which part is going to cancel? Y. And then Brady, what's left over? X. Okay, and you're done. So it's the same answer, but please make sure you do this carefully. All right, let's have you guys move on to number 2. If you're done, let me check it. All right, we are going to do method 1. Okay, so add the fractions together separately. In the numerator, what is the least common denominator? Okay, talk to your partner. What is the least common denominator in the numerator?
X plus 1.
What is the least common denominator in the numerator? Talk to your partner. You gotta figure this out. Okay, Josh and Rula, what is the least common denominator in the numerator? Nope. Andrew and Alana? Least common denominator. What do they both share? Huh? X squared plus x, yes. So then it's x times x plus 1. So this guy needs an x plus 1. This guy needs an x. Okay, let's do this one more time. Talk to your partner. What is the least common denominator? Okay, Sam and Alice, what is the least common denominator in the denominator? No answer? What's the least common denominator in the red one? X plus, X plus 1? Yeah, x plus 1 times x minus 1. So this needs an x plus 1, and this needs an x minus 1. Okay, continue. Finish this problem. All right, in the numerator, x squared minus 2, x squared minus x minus 2 plus 2x over x times x plus 1. Denominator. Remember, just write it all together. Oh, okay, Andrew has a, squint. So
I'm confused how you got normal x instead of 2x.
Normal x instead of 2x. I did it really fast in my head. So instead of foiling, I already know that the plus x and the minus 2x is going to combine, and then you just have a minus x.
Oh, okay.
Yeah. Okay, in the denominator, 3x plus 3 minus x minus 1 all over x plus 1 x minus 1. So I don't multiply any denominator together because there's a possibility they will cancel, and then so if you multiply them together, it's hard to cancel later. Okay, simplify. In the numerator, you get x squared plus x minus 2 over x times x plus 1 all over 2x plus 2 over x plus 1 x minus 1. Okay, now divide. X squared plus x minus 2 over x times x plus 1 divided by 2x plus 2 over x plus 1 x minus 1. Okay, that x squared plus x minus 2 is actually factorable. So this is x plus 2, x minus 1. And then we're going to multiply by the reciprocal. So that is x plus 1, x minus 1 over, and then I'm going to factor that as well. Now we're looking for things that we can cancel. So you can see that this cancels. Is that it? Did I do something wrong? I think there was one more thing I can cancel.
That's supposed to be x minus 2. Oh, wait.
X plus 3? 3x plus 3. Yes, but... Oh, I see. Okay, I don't remember what I did wrong. Sorry about that. Oh, thank you. The final answer is x minus 1 squared over 2x. But let me show you method 2. Method 2 will take you probably a minute instead of 5. So what you want to do is multiply everything by the least common denominator, which is x plus 1, x minus 1. You're like, this is not much better. Okay, So multiply this together, you get x cancels out, you have a leftover of x plus 1, x minus 1, x minus 2. When you multiply this together, you have a 2x and then x minus 1. In the denominator, 3x, x plus 1. And this one, x and then x minus 1. Everyone's like, I'm ready to go. Okay. I will finish this 1 second.